Right. So today we're diving deep into this guide all about breaking down those tough programming problems.
Yeah.
You know, the ones that make your head spin. But here's the thing. Even if you aren't a coder,
Mm-hmm.
these strategies are like gold. You know,
Yeah,
that's for
absolutely.
tackling anything, really.
This guide is all about problem-solving skills.
Right.
And I think that's something we could all probably use a little boost in,
Yeah.
wouldn't you say?
Oh, for sure. And the way this guide lays it all out,
Mm-hmm.
it's like you suddenly get this superpower for like untangling any messy situation.
Right.
But why is breaking things down even that important?
Okay, so,
I mean, it seems kind of obvious, but
yeah.
is there more to it than, meets the eye?
Oh, there's definitely more to it.
Okay.
Have you ever, like, tried to juggle a dozen tasks at once?
Yeah.
It's just chaos, right?
Oh, yeah. Tell me about it.
Yeah.
My brain feels like it's short-circuiting, like half the time.
Exactly. Our brains are really wired to handle things like sequentially, step by step. And when we try to process too much at once, we just like miss crucial details.
Yeah.
We make mistakes.
Yeah.
We get overwhelmed.
Makes sense.
So breaking things down isn't just about like being organized. It's actually about
Okay.
working with how our brains are actually wired.
So it's like we're not just making things easier.
Yeah.
We're making ourselves like smarter in the process.
Exactly. And that's a really powerful concept to grasp, I think.
Yeah.
And this guide emphasizes that point beautifully. It really argues that problem decomposition,
Okay.
which is just a fancy term for, breaking things down,
Right.
actually taps into our cognitive strengths.
Okay.
So it allows us to, focus, analyze, and
Mhm.
solve more effectively.
Okay. I'm starting to see this in a whole new light.
Oh.
Now, this guide lays out this fantastic 6-step framework for doing just that.
Right.
And they use this interesting example in there about palindromes. You know, those words that read the same backwards and forwards, like race car
Yeah.
or madam.
Exactly.
So how does finding a palindrome, like, fit into all of this?
So let's say the challenge is to find the longest palindrome within a jumbled string of letters.
Okay.
The guide uses that as a model
Okay.
to show how this 6-step framework can be applied.
All right. I'm intrigued. Let's walk through it.
Okay.
What's step 1?
Okay. So step 1, and this might seem kind of obvious, but
Mhm.
is to fully understand the problem.
Okay.
And it's not just about reading the instructions.
Yeah.
It's about like really dissecting them.
So in our palindrome puzzle,
Yeah.
it's not just knowing what a palindrome is,
Okay.
it's figuring out what we're supposed to do with it.
Precisely. And this step, like as basic as it sounds,
Right.
is actually where a lot of people trip up.
Okay.
They rush into solving before they really grasp what's being asked.
Oh, that's so true. It's like trying to assemble furniture without reading the instructions.
Yeah,
You just end up with like extra pieces and a whole lot of frustration.
exactly.
Yeah.
Taking the time to really understand the problem thoroughly,
Mhm.
clarifying any ambiguities, it really sets you up for success from the get-go.
All right. Step 1, understand the problem. Got it. What's next?
Okay. So step 2 is all about identifying the inputs and outputs.
Okay.
Think of it like baking a cake.
Right.
You need to know the ingredients you're starting with
Mm-hmm.
and what kind of cake you want to end up with.
So in our palindrome case,
Yeah,
the input would be that jumbled string of letters.
right. That's what we're feeding into our, problem-solving machine.
Okay.
In the output, that would be the longest palindrome that we can extract from that mess.
So knowing these clearly helps us like define the problem
Mm-hmm.
and maybe even like point us towards the right tools for the job. It's like if you know you're baking a chocolate cake.
Yeah. You know you'll need cocoa powder.
Exactly. You're
Yeah.
thinking like a true problem solver now.
All right.
All right. Ready for step 3.
Hit me with it.
Okay. So step 3 is like the heart of the process.
Okay.
It's breaking down the problem into smaller sub-problems.
Right.
But like taking that giant intimidating monster of a problem
Right.
and just chopping it into like bite-sized pieces.
Ooh, I like the sound of that.
Yeah.
So for the palindromes,
Mhm.
how would we even begin to break that down?
Well, you would first need to figure out how to generate all the possible substrings
Okay.
from that jumbled string of letters.
Okay, so like every possible combination of letters
Yes,
within the original string.
exactly.
Got it. Then what?
Then you need to write the code to check if each of those substrings
Right.
is actually a palindrome.
Okay.
And of course, you need a way to keep track of the longest one that you find along the way.
This is starting to feel a bit code heavy, but
I'm following the logic.
and that's the beauty of this framework. It works whether you're writing code or like organizing your sock drawer.
Right.
The key takeaway here is that by breaking things down,
Sure.
we make the problem less intimidating, and we create a clear roadmap for for tackling it.
I'm already feeling less stressed just thinking about it.
Right.
So we've broken the problem down. We solved each little piece. What's next? Do we just like throw it all back together and hope for the best?
Not quite. Step 4 is where we take all of those mini solutions
Okay.
and we combine them into a cohesive whole.
So this is where things get pieced back together.
Yeah.
Like in our palindrome example, we take the code for generating substrings, the code for checking for palindromes, the code for keeping track of the longest one,
Yeah.
and integrate it all into like one smooth running function.
Precisely. And this step often involves some creative thinking,
Yeah.
some fine-tuning, but just making sure everything works in harmony.
Yeah.
It's like putting together a puzzle. You've got all the pieces. Now you need to assemble them into the final picture.
And I bet the feeling of accomplishment is pretty similar too.
Oh, you bet. But our problem-solving journey isn't quite over yet.
Oh, fine.
Step 5 is all about optimization and refinement.
So we've got a working solution.
Yeah,
Now it's time to make it shine.
exactly. We're looking for ways to make our code run faster, use less memory,
Okay.
maybe even find like a more elegant solution.
So in our palindrome quest,
Yeah.
we try to find a more efficient way to actually identify the longest palindrome.
It's not just about finding a solution. It's about finding the best possible solution.
Oh, I like that.
Yeah.
Taking something good
Mm-hmm.
and making it even better. But this framework,
Yeah.
it seems like it applies to so much more than just coding.
You're absolutely right. This 6-step process can be applied to anything from planning a complex marketing campaign
Okay.
to organizing your overflowing closet.
It's like a universal problem-solving toolkit.
Yes.
This is mind-blowing.
Right.
But
Yeah.
before we get too carried away,
Right.
we haven't even touched on those advanced techniques
Yeah.
that the guide mentioned.
Yeah.
Dynamic programming, greedy algorithms,
Mm.
divide and conquer.
Mm-hmm.
They sound so intimidating.
They do have a certain ring to them, don't they?
Yeah.
But trust me, they're not as complex as their name suggests.
Right.
And once we break them down, you'll have even more tools in your problem-solving arsenal.
Yeah. All right, you've piqued my curiosity. Let's unravel these advanced techniques
Yes.
in part 2 of our deep dive. I'm ready to level up even further.
All right, let's do it. Okay, so are you ready to unlock some next level problem solving techniques?
Yeah, let's do it.
All right, we're about to dive into the realm of dynamic programming, greedy algorithms, and that classic divide and conquer.
We've got our 6-step framework down,
Mm-hmm.
but I'm ready to supercharge my skills,
Yeah,
with these advanced strategies. They sound a bit like secret weapons, though.
they do have a certain like aura about them, don't they?
Yeah.
But I promise, once we break them down, you'll see how practical and surprisingly intuitive they can be.
Okay.
Let's start with divide and conquer. Imagine you're facing like this mountain of data that needs to be sorted.
Okay. I'm picturing a spreadsheet with like a million rows all in
Yep.
random order.
Exactly. Now, instead of tackling that whole mess at once,
Right.
what if you split it into smaller, more manageable chunks?
So like break it down into sections,
Yeah.
sort those individually,
Hmm.
and then like merge them back together.
You got it. And that, my friend, is the essence of divide and conquer. A classic example of this is the merge sort algorithm.
Okay.
It takes a huge list, divides it in half, sorts those halves,
Right.
then merges them back into a, perfectly sorted whole.
It's like a super efficient sorting assembly line.
Yes.
Each step is simple,
Mm-hmm.
but the combined effect is incredibly powerful.
Exactly. And the brilliance of divide and conquer is that it reduces complexity exponentially.
Okay.
So instead of struggling with like a million rows,
Right.
you're dealing with smaller, more digestible chunks.
Okay. Divide and conquer is officially added to my problem-solving toolkit.
There you go.
But what about dynamic programming?
Yeah.
That one always sounded a bit mysterious to me.
It does have a certain mystique, doesn't it?
Yeah.
But it's actually a very elegant concept.
Okay.
Imagine you have a superpower that lets you instantly remember the answer to any problem that you've solved before.
So like a mental cheat sheet for life.
Yeah.
That would be awesome.
And that's what dynamic programming does.
Yeah.
It stores the solutions to sub-problems, so you never have to waste, time and effort recalculating them.
So it's all about optimizing for efficiency.
Yes, exactly.
Okay, I'm starting to see the appeal.
Right.
But how does this actually play out in the real world?
Okay.
Can you give me an example?
Absolutely. Think about calculating the Fibonacci sequence.
Okay.
You know, that series of numbers where each number is the sum of the two preceding ones?
I remember that from math class. 1, 1, 2, 3, 5, 8.
Exactly. Now, with dynamic programming, as you calculate each number, you store the result.
Okay.
So the next time you need that same calculation, you can just pull it from memory instead of doing the whole calculation again.
So it's like building a library of solutions as you go along. That's really smart.
Yeah.
And it seems like it would save a ton of time and energy.
Yes.
Especially with complex problems.
It absolutely does. And the best part is this concept can be applied to so many different scenarios.
Okay.
Not just coding.
Oh, wow.
Think about, route optimization for deliveries.
Okay.
Financial modeling. Even game theory.
Wow.
Dynamic programming is, it's everywhere.
I'm starting to see dynamic programming in a whole new light.
Good.
Okay. Now for the last one, greedy algorithms.
Okay.
That name always made me think of, being a bit greedy.
It's a fitting name, isn't it?
Yeah.
Greedy algorithms are all about making the best looking choice at each step, hoping that those choices will lead to the best overall solution.
So it's like choosing the most delicious looking donut in the box first.
You got it.
Okay.
It's about grabbing the most appealing option in the moment without necessarily considering the long-term consequences.
But doesn't that sometimes backfire?
They can.
Like, what if the best looking donut is actually the least satisfying one?
That's the trade-off with greedy algorithms.
Okay.
They don't always guarantee the absolute best solution.
Right.
But they're often surprisingly effective and incredibly efficient.
Okay.
They're like a shortcut, a quick and dirty way to get a pretty good result in many cases.
So it's like choosing speed and simplicity over like guaranteed perfection.
Exactly.
That makes sense.
Yeah.
But can you give me an example of how this works in practice?
Sure. Imagine you're trying to figure out the fewest number of coins to make up a certain amount of money.
Okay.
A greedy algorithm would say, okay, let's start by using the largest coin possible, then the next largest, and so on. It might not always give you the absolute fewest coins, but it's often a close approximation.
Right.
And way faster than trying, every possible combination.
So it's like a quick and dirty way to get change.
Exactly.
It might not be perfect, but it gets the job done.
Exactly.
Okay, so we've got divide and conquer for breaking down problems into similar pieces. Dynamic programming for remembering past solutions.
Right.
And greedy algorithms for grabbing the best-looking option at each step.
Yeah.
These are some seriously powerful tools.
They are indeed. And the beauty is they're not just limited to coding. You can apply these concepts to all sorts of challenges in life.
Okay.
From planning a trip to managing your finances.
Right.
These strategies can help you make smarter decisions and find more efficient solutions.
I'm already starting to see how these techniques could be helpful in my everyday life.
Yeah.
But I have to admit, the thought of applying all this in a high-pressure situation like a technical interview makes me a bit nervous.
Technical interviews.
Yeah.
They can be a bit daunting.
Yeah.
But the guide has some excellent advice on how to how to ace those.
Okay.
And guess what? It all comes back to problem solving.
All right. I'm all ears. Yeah. How can we impress those interviewers with our newfound problem-solving prowess? Okay, so we've got our problem-solving framework. We've unlocked some seriously cool advanced techniques, but how do we bring it all together to, like, really nail a technical interview?
Well, here's the secret sauce. Interviewers, they aren't just looking for, the right answer. They're looking for how you think.
Okay.
They want to see your thought process in action, your ability to analyze, strategize, adapt.
So it's like showing them how our brains work.
Yeah.
Like how we approach challenges step by step.
Exactly. And one of the best ways to do this is to think out loud, verbalize your thoughts, explain your reasoning, walk them through your decisions as you make them.
It's like giving them a front row seat to our, problem-solving process.
Precisely. And this does a couple of things. It demonstrates your communication skills,
right,
which are, crucial in any tech role.
Yeah.
And it allows the interviewer to, guide you if you get stuck.
So even if we hit a roadblock, talking through it can actually be a good thing.
Absolutely. It shows that you're not afraid to ask for help, that you're willing to, learn and collaborate. Remember, interviews are a two-way street.
Okay. Think out loud, check.
Yeah.
Any other tips for impressing those interviewers?
Another great strategy is to start with a brute force solution.
Brute force. Does that mean we just we attack the problem with the first solution that comes to mind?
It's a bit more strategic than that.
Right.
A brute force solution is the simplest, most straightforward approach. Okay. Even if it's not the most efficient or elegant.
Okay.
The idea is to get something working first.
Right.
Then optimize from there.
So it's like building a solid foundation before we start adding the the fancy architectural details.
That's a great analogy.
Thanks.
A brute force solution shows the interviewer that you can solve the problem, and it gives you a starting point for improvement.
Okay, so start simple, then iterate and improve. What comes next?
This is where those advanced techniques that we talked about come into play.
Right.
Analyze your brute force solution. Can you apply divide and conquer to break it down into smaller pieces? Can you use dynamic programming to avoid redundant calculations? Could a greedy algorithm provide a quicker, though potentially less perfect solution?
So it's like having a whole toolkit of problem-solving strategies at our disposal.
Exactly. And choosing the right tool for the job shows a deeper understanding of the problem and a mastery of, different approaches.
This is all making so much sense now.
Good.
But there's one thing I still get tripped up on. Time and space complexity.
Yeah.
What are those exactly, and why do they matter?
That's a great question. Time complexity refers to how the runtime of your code increases as the input size grows.
Okay.
Space complexity refers to how much memory your code uses.
So if my code takes forever to run or eats up all the computer's memory, that's a bad sign.
It could be.
Okay.
In the real world, efficiency matters. Interviewers want to see that you're not just focused on finding a solution, but on finding an optimal solution that performs well under pressure.
Okay, so keep time and space complexity in mind. Got it. Anything else we should be aware of?
Don't forget about edge cases.
Okay.
Those tricky scenarios that might not be immediately obvious, but could cause your code to break.
So like thinking about all the what-if scenarios to make sure our solution is truly bulletproof.
Exactly. By anticipating their edge cases, you demonstrate thoroughness, attention to detail, qualities that any good programmer should have.
This is fantastic advice.
Yeah.
It's amazing how these problem-solving principles can be applied not just to coding, but to any challenge we face.
You've hit the nail on the head.
Right.
We've learned how to break down complex problems, apply advanced techniques, and even, shine in those sometimes scary technical interviews.
Yeah.
But it goes beyond that. We've gained a new way of thinking, a mental framework for tackling complexity with, confidence and clarity.
It's like we've unlocked a hidden superpower.
Yeah.
And the more we practice, the stronger it gets.
Exactly. And who knows, maybe there are even more hidden problem-solving techniques out there just waiting to be discovered.
Ooh, that's a fascinating thought.
Yep.
What other strategies might we find to conquer complexity and achieve our goals? It's an exciting journey of continuous learning and improvement.
It certainly is. And for all of you listening, we challenge you to take these principles and apply them to something that you've been putting off, something that felt too complex or overwhelming.
Right.
Break it down, apply the framework, and see what you can accomplish.
You might just surprise yourself with what you're capable of.
Yeah.
Until next time, happy problem solving, everyone.